The key system descriptions for airborne energy systems, of course, the Doug Selsam Superturbine idea, um, relying on a shaft with attached blades of, in Doug's favorite description, stiff blades. You could mount a shaft way up high. This is an example of one of these shafts, but with inherent buoyancy added in with bags and a hydrogen bleed system. So if you look at that red line there, imagine you had an encased sheathed tether in that line. And inside that tether, a very fine weave braiding. So sort of maybe a Dyneema, maybe other, a strong tether, finely braided and sheathed. So not only is that red line taking a lot of tension, it's also filled at the bottom with high pressure hydrogen. Because of the fine weave, hopefully you'll be able to diffuse through it, but not have gaps in it larger than 0.6 millimeter, or even lesser, hopefully, smaller gaps. Sorry. But the reason for that would be that you'd be able to douse any, say there was an ignition in one of these balloons, these bladders, these bags, and you'd be able to stop that spreading along the system. It wouldn't go into a supersonic detonation kind of explosion, as this sheeting would just be an airbag stretched between the balloons, the buoyancy, the hydrogen balloons. So you'd only have an airborne hydrogen explosion if something was to go wrong, and it's hard to contain since these are very thin like bags. So you're not going to be creating a large area of damage if something does go wrong. The stretched sheath would be able to transmit a bit of torque, as long as it's in tension, depending, of course, on the diameter of the balloons and the diameter and the tension between each point. To achieve torque transmission down the tube here, rather like before where we talked about the penis model, where there's an outer sheathing with a cross-woven structure, and whatever we have as our final outer sheathing, whether it's this one layer or several layers of pipes or maybe more balloons inside this one pipe, we'll have to have that cross sheathing on the outside, preferably, so that tension in the outer sheathing is able to transmit torque, making the tube rigid and able to transmit torque down to the bottom. Maybe that layers of these shafts are best run together. So let's say you had a circle of another 6 shafts around about this one, and on that another circle around about that even further. So you end up with thickening it in that way. So you're able to spin the whole bunch together, creating a greater torque through the whole system.